Hi, I'm Alex Lamb and you're watching the third in my thrilling group selection series of videos in which I attempt to uncover or explore the source of human altruism, or indeed altruism for any species that choose to live together in little kind of happy sort of nesty things like bees or ants or naked mole rats or whatever you like, reef shrimp even. Anyway, the point is we're going to find out. Last time I promised you that I was going to show you the simulation in action, but what happened in the last video is I instead took you on a slightly protracted tour of my Java code. But this time we're going to get straight to the stuff. We're going to show you the simulation in action. Here we go, ladies and gents. But we're going to do the first time out, just so you know what's going on, is we're going to run it quickly and make it pause, so that we can actually understand what's going, because check this out, I've gone to crazy town on the visualizations, and that's so that we can look at what's happening in simulation in many different ways at once. So, whoa, we've got dots and tiny balloons and 1980s style readouts and things. What's happening? I'll try to very quickly explain. Up here, we've got disks. Red disks means lots of defectors. White disks means lots of cooperators. And they wander around in a space that tells you whether or not they're sick or healthy and whether or not the society is kind of equal or really hideously unequal. Panel number 2, we've got a line for every single tribe, and every tribe has a colour. And if the line is going up, it means a whole bunch of defectors are being born. If the line goes down, it means that the tribe has a lot of cooperators in it. Panel number 3 tells you how old that tribe is compared to its oldest agent, because we need to know whether or not, if we've got a situation in which people live in 6 different tribes before they die, we know that something's wrong with the dynamics of our sim. Okay, panel number 4. This is another feature space thing. Every dot represents a tribe, and we've got them wandering around here. They move over from left to right if there's a bunch of defectors. And likewise the other way for cooperators, they move up if they're healthy, down if they're sick. You get the general idea. This one tells us what the DNA of all of the agents in the simulation is. We start off with agents related to everyone in their tribe and not related to anybody else. And over time we're going to see some kind of a mixing up. And we're interested in that because if one mutation dominates, we should expect kin selection to be true. If a whole bunch of mutations happen in parallel, something else weird is taking place. Last panel, ladies and gents, this tells us who's more healthy in a given tribe, cooperators or defectors. Because if the cooperators, in other words, if we've got tribe dots down here, there's something wrong with our sim, because the kind of people who accept pie from their neighbours without ever handing any out, they should be doing better than people who spend all their time lost in a fugue state of endless baking and never getting to eat anything. Anyway, you get the idea. Let's press the button. We'll go to the actual live tribe experiment and hit go and see what happens. Moment of truth, ladies and gents. Which model is true? Okay, over in the top left-hand corner, we've got a bunch of disks moving around. Oh, we've got some whole tribes going to red. We've got some bubbling around. We've got a bunch of lines moving up and down in a kind of a crazy and deeply overburdened plot over time, but it still looks cool, so who cares, right? So we've got lines moving around. We've got the, as time goes on, the tribes are getting older and the agents seem to be sort of new tribes are being made and marching out from the left, and as people die they drop down here. In the feature space we see these crazy balloons wandering around like balloons. And over here we've got a whole bunch of lineages still in place, lots of different families all succeeding, defectors doing better than cooperators. That's kind of what we'd expect. But wait, ladies and gentlemen, what is happening? Let us go back to the top left-hand panel, because something interesting has happened. The disks are slowly going white. Even though we had a whole bunch of lines trending up and defectors winning over time, the main bulk of the simulation is moving down, suggesting that cooperators overall are winning. And yet, look down at our 80s display down here, we still have at least 5 different family lineages in action. Could it be, ladies and gentlemen, that group selection is actually winning out? Do we trust this result? With our science hats on, do we really believe this? Well, certainly we shouldn't just yet, because what we're going to have to do is look at the simulation running 1,000 different ways, collect the results together, and then science the ever-living heck out of them. And that's what I've done for you, ladies and gents. So in the next set of slides and things, the next video, I'm going to show you what happens if we explore this whole exciting regime. Maybe we'll even look at another simulation run. But remember, ladies and gents, the whole point of this is to show you that the frontier of human knowledge is right next door. We can all participate in the process of learning about a charged and chewy topic in complex systems and evolutionary biology research that's got 140 biologists involved in a giant science fight. So remember that, ladies and gents, and also remember, I write awesome novels. Don't forget that. That's key. Anyway, you get the general idea. Tune in next time, ladies and gents, so when we find out what the actual truth is.